So here we have a sum of n terms, and we want to find the limit of the sum when n approaches to infinity. So how do we do this? Let's think of this as nth term, so an. So an equals to 1 over 4n squared minus 1, that's difference of two squares. So we can write as 2n plus 1, 2n minus 1. And then by partial fractions, we can do partial fractions. We get a half of 1 over 2n minus 1 minus 1 over 2n plus 1. Camera is covered that far. So let's rewrite xn, the sum of n terms. So when n equals 1, let's pull this half outside. When n is 1, 2 times 1 is 2, 2 minus 1 is 1, 1 over 1 is 1. Then 2 times 1 is 1. 2 plus 1 is 3, so minus 1/3. Now when n equals 2, I still have the half, but the half is pulled outside. So 2 times 2 minus 1, that's lost 1/3. Then 2 times 2, 4 plus 1, 5. Then when is 3, n is 3, 2 times 3, 6 minus 1, 5. Same thing, minus 1 over 6. So on and so forth until the nth term. Nth term is this. Now we see many terms cancelled, right? These two additive inverse means they add up to be 0, right? So on and so forth until this one. So what's left? We're left with a half of this 1 minus this last term. Now let's take a limit of this. Limit when n approaches infinity. Limit, let me erase this. Right. I have to add a limit everywhere to be mathematically correct. Right. Now take a limit of this. When n, this is n, not x. When n approaches infinity, 2n plus 1 approaches infinity. So 1 over infinity, that's 0. Think about it, one apple shared by the whole wide world of people. How much apples can each one get? 0, right? So this term tends to 0 when n approaches infinity. So I'm left with limit of n approaches infinity. Half times 1 is half. Limit of a constant, it's just a constant. So the limit of this equals 1 over 2.